have learned from the router 2. Because of that, in the routing table, we will have D means the EIGRP, then 10400/24 with the next stop of the router 2. This is the mechanism that we have in the EIGRP. Actually, in EIGRP, first we are establishing the neighborship between the routers. After that, we are advertising the EIGRP updates. And finally, in the topology table, we have multiple routes, okay? And after that, we are selecting the best path and using that best path in the routing table. Also, in EIGRP, we have one important benefits in compare with another protocols. What is the benefit? Assume that the higher pass failed. This means that now we don't have this higher pass. After the higher pass failed, because you know that in topology table, after this fail, we will lose the EIGRP neighborship, and this means that the information received from the R2 now is not valid. Because of that, the information received from the R2 should be removed from the topology table, and immediately after the fail, the next best path can be injected to the routing table. And now we have the next stop of R3. This means that when you are forwarding traffic to the router 2 and the link failed, you can easily and with a suitable speed, good speed, you can convert traffic or to the router 3. This means that one of the most benefits of the EIGRP in compare with another protocols is the EIGRP fast convergence. Maybe the EIGRP is the has the highest speed about the convergence in compare with the, for example, OSPF, ISIS, RIP, or also BGP. Because of that, this is one of the benefits of the EIGRP. Very good. Until now, we have learned that in EIGRP we have three tables: neighborship table, a topology table, and then routing table. The first table that is populating is the neighborship table. The second table is topology table. And the third table is the routing table. You will learn about the detail of these tables and also detail of the contents of this table. But we can say the main function of the EIGRP can be seen in this scenario. Also, we have many, for example, details and some other things that you will learn about them. I think the best way to understanding the EIGRP is implementing one simple scenario such as this scenario and experiencing some of these details step by step. You can understand more and more. Because of that, let me to talk about the configuration of this simple scenario, and after that we can continue our learning process, our learning journey about the EIGRP. Let me to talk about the configuration of the EIGRP. In EIGRP, we have two types of configuration. The first type is calling the traditional EIGRP configuration, and this is the old method of the configuration of the EIGRP, but now we have a newer method. We call it the named EIGRP configuration. In this class, I'm going to talk about both method, traditional and also named. This means that we can configure one router with traditional configuration, another router with named configuration. Also, let me to emphasize that the newer features of the EIGRP are only available in the named configuration. Because of that, it is better to configuring with the newer method or the named method. But it is possible that in some cases your router doesn't support the named configuration. Because of that, in this class we are using both methods. Actually, I am trying to show you both method, but let me to say that you will see that the named method is the more efficient method. Okay, I will show you and I will talk about that. Let me first talk about the traditional configuration. In each scenario, I am trying to show you both method. Okay, traditional configuration of EIGRP. In traditional configuration of the EIGRP, we need to use the router EIGRP, then the AS number. Router EIGRP AS number. This means that we can configure one EIGRP process in one router with the router EIGRP AS number. This is the AS number of can be the AS number of the organization, or can be a fake AS number. It is better that if your organization has AS number, you use this the real AS number of your company. And let me to emphasize that in one router, we can configure more than one EIGRP process. For example, assume that here we have router 1 and router 1 connected to 2 network. Okay, we want to configure 2 EIGRP process. The first for this network, the second is for the second network. Okay, and router EIGRP 1, router EIGRP 2. Actually here the AS number is a for example process ID. Okay, this is like a process ID, means we can configure 2 processes of the EIGRP. Okay, in most cases we are using one AS number, one EIGRP AS number in our company, but if you want, you can use this AS number to separating 2 EIGRP process in one router. Okay, this is different than the BGP AS number. For example, it's better if your company has the AS number using the AS number of company. Okay, let me to show you what is happening. After this command, you will go to the router config router mode. Here you should select which interface should be enabled in EIGRP process with the network statement. In the CCNA class, you have learned about the wildcard mask. Here again we are using the wildcard mask. For example, network, then interface IP. Don't forget this is the interface IP, not the network address. And after that, wildcard mask. Wildcard mask is optional. Let me to show you one example. For example, here we have R1. R1 has 2 interface. The first interface IP address, this interface, okay, has the 10.1.1/24 or 10.1 for example 0.1/24. This is the this interface. Okay, and the second interface's IP address is 10.1.2.1/24, and you want to enable EIGRP in this router. You can configure this command, router R1 config router EIGRP 1. The 1 is the AS number. Okay, and this is the for example identifier for this EIGRP process. Then router config router. Okay, you can use the network 10.1.0.1 quad 0. Quad 0 in wildcard mask means exactly this IP address. Okay, you have learned about the concept of the wildcard mask. Okay, network 10.1.0.1 quad 0 means exactly on the interface with the IP address of 10.1.0.1, the EIGRP should be enabled, means this interface. Okay, and also because we have 2 interface and we want to enable EIGRP on both interface, we should use again network 10.1.2.1 quad 0. That's it. And here it means only on the interface with the IP address of the 10.1.2.1 the EIGRP should be enabled. But let me to show you another method for configuration. Look at here, you can configure again router config router EIGRP1 R1 config router. Okay, and then using this command network for example 10.1.0.0.0.255.255. As you can see, this wildcard mask means all of the interfaces IP address that start with the 10.1, okay, and without regarding to the octet 3 and octet 4, okay, should be enabled in EIGRP. This means that the this interface 10.1.0.1 and this interface 10.1.2.1, as you can see, both of them are using 10.1 in the first octet and the second octet. Because of that, with only one command we can enable EIGRP on these 2 interfaces. Also, let me to show you another method, router config. Okay, router EIGRP1, then we can use R1 config, then router network, okay, quad 0, then quad 255. What does it mean? It means that on all IP address, because the wildcard mask quad 255 means on all IP address, on all interface with any IP address, the EIGRP should be enabled. Okay, because of that, with the different type of the wildcard mask, we can configure EIGRP on the interface of one router. But the best method is the more specific method. For example, if you use this method, the last method, okay, the configuration may be easier, but Here, when you are one interface and you don't want to add that interface to the EIGRP, you will have a problem. Because of that, it is better to selecting one by one each interface with the more specific wildcard mask quad 0. In this class, I am going to use only